Welcome to Module 1, Lesson 21, Getting the Job Done, Speed, Work, and Measurement Units. So after today's lesson, I'd like you to be able to use rates between measurements to convert measurements in one unit to measurement in another unit, and also manipulate and transform units appropriately when multiplying or dividing quantities. So basically we want to be able to transfer between units and to make sure to do so correctly with multiplication or division. Alright, so I'm going to turn on my revealer tool here so we can go step by step. Now we have some vocabulary here. This vocabulary did not get put into your packet, so I need you to write these down on your own, the word, the definition, and the example. Alright, so the first word that we're going to look at here is length. Length is the distance from one end of something to the other end. So when you're measuring length, you're measuring from one end to the other, whether it be from top to bottom, left to right, just from one end to the other. So questions for length would be, how deep is it, or how deep is the pool? Depth would be a type of length. How far is it from? These are questions that you'll hear that tell you that you are looking for the length. Capacity. So we hear this word often, but we need to know what it means in order to know what we're measuring. So capacity is the amount a container can hold when filled. So on the bus you see capacity 64. That means the bus, the container that is the bus, can hold 64 students when it is full. We're talking about capacity in terms of pretty much liquid measurements here. So when we talk about capacity, we're asking how much can it hold? Then moving on, we have weight. Weight is the measure of how heavy something is. So weight and mass are different. Weight involves gravity. So you would weigh a different amount on Earth than you do on the moon. Because with weight, it's accounting for the gravitational pull against your body. So when you stand on the scale, your body is being pulled onto that scale by gravity. So it's including that gravitational pull for weight. We're not going to get that in depth with using it. We just want to be able to convert between them. But I do want to make sure you understand that weight and mass are two different things. They have the same general idea, but they actually mean two different things. So here when we say how much does it weigh? What is its weight? How heavy is it? These are all questions that would involve the answer for weight. Okay, so again, this is your word, definition, examples. Now mass is different. Mass is the measure that, it measures the amount of matter in an object. So basically like how full of stuff are you, or how full of stuff is a bowling ball? Like what's all in there? What is the measurement of that? That would be mass. Mass does not include gravity because it's just measuring what is inside of that object. So mass, your mass is the same on Earth as it would be on the moon. And then for mass, we say, what is the mass? So when you see a question like that, they're talking about mass. Typically, we just use mass when it comes to the metric system. Right? It's a good segue into our next one. So the U.S. customary system is a method of measurement used in the U.S. There are actually only 3 countries in the entire world that use the U.S. customary system. All you need to know though is that it's the system that we use in the United States. And that system involves, so for length, it's inches, feet, yards, and miles that we measure with. For capacity, we measure in fluid ounces, cups, pints, quarts, and gallons. Yes, please make sure all these are written down. So if you need to pause and get everything written down. Weight is measured in ounces, pounds, and tons. Notice we have ounces and we have fluid ounces. Those are two different things. Fluid ounces, again, measures capacity. So when you look at a water bottle, it says it holds 16 fluid ounces. That is different from 16 ounces. Ounces measure how heavy something is, its weight. They are different. They are not equal to one another either. Okay, another thing that I notice a lot is here with length. In the US customary system, we do not use centimeters. Okay, so you gotta get that out of your head. So if I ask you to measure something and what unit would you measure it in, you would not tell me centimeters if I ask you to measure it in US customary. Okay, and then the next one would be the metric system. The metric system is a method of measurement using base 10. So everything is by tens. So if there's 10 of this, then if you want to go to the next level, you would divide it by 10, and that would give you the measurement. Okay, so then here, for length, we measure in meters. Capacity, the base unit is liters. And mass, the base unit is grams. Now, there are several different units for each of these, but it's the prefixes that are different. So I'm showing you just the base unit, and I will give you all of the prefixes over here. So we have, you can have kilo, meters, liters, and grams. Hecto, meters, liters, and grams. Deca, meters, liters, and grams. And then you have your base units, which are these, and then deci for the prefix, centi, milli. So what I mean by base 10 is that if you have, let's say you have 10 centimeters. Well, millimeters are smaller than centimeters. So when you go from centimeters to millimeters, inside of each of these centimeters is 10 more millimeters. So 10 centimeters would be equal to 100 millimeters. That's what I mean by base 10. So every time you go down a stair, you multiply by 10. So if I have one of these, that's 10 of these, 100 of these, 1,000 of these, 10,000 of these, and I'm going to erase this here so you can see more clearly. 100,000 of these, and 1 million of these. So basically, no matter what you're measuring, meters, liters, or grams, if you have 1 kilo of them, that means you have 1 million millis of them. All right, so now we're going to identify the ratios that are associated with conversions between feet, inches, and yards. So we know that 12 inches is equal to 1 foot. So the ratio of inches to feet then would be 12 inches to every 1 foot. Going in reverse, 1 foot is equal to 12 inches. So the ratio of feet to inches is 1 to 12. And yes, it is important to note the order because when you're converting between the units, you need to make sure that you're using the correct thing to multiply by. Here you have 3 feet is equal to 1 yard. So the ratio of feet to yard is for every 3 feet, you get 1 yard. And here 1 yard is equal to 3 feet. So the ratio of yards to feet is for every 1 yard, you would have 3 feet. All right, so now we're going to move on to actually using the conversions. So I'm going to take off the revealer. So first what we're going to do is we're going to make a ratio table that compares feet and inches and find how many feet are in 48 inches. So again, highlighting, make a ratio table, compares feet and inches, and then how many feet are in 48 inches. For my sentence, I would say there are blank feet in 48 inches. All right, so I want you to create your table. Make sure you have your feet and you have inches. So in this top box, you should have your labels. And then here would be your numbers. So I want you to pause, create that. When you come back, we'll check your answer. All right, so you should have had feet and inches. If you had inches over here and feet over here, that's fine. I just chose to set it up this way. It doesn't matter which side you put it on, as long as your numbers are correct. So for every 1 foot, I have 12 inches. For every 2 feet, I have 24, times 2, times 2, times 3, times 3, times 4, times 4. So I know that my answer then would be that there are 4 feet in 48 inches. So again, we can use a ratio table to justify our answer or to help us find our answer. However, we also want to be able to use multiplication, so we want to keep practicing with that. So this is where your ratios come into play. So I am comparing, I'm going from inches to feet. So when I go from inches to feet, I want to use the value that compares feet to inches. We talked about this, how you use the kind of the opposite value. So we know that the ratio of feet to inches was 1 to 12. So then the value would be, oops, and I wrote it this way for us before. So then the value in this case would be 1/12. To make sure we're using the right thing, look at your table or look at what you know. If I take inches and multiply it by 1/12, does it give me feet? And it should, because this is a fraction. This isn't a whole number, this is a fraction. And when I multiply by a fraction, my number gets smaller. Okay, so what I would do is I would take my 1 foot, and I am going to use labels here so we can remember how to work with them and how they cancel each other out. 12 inches. And I'm going to multiply that by what I have. And in this case, I have 48 inches. And I know I put that over 1. Here, my inches cancel out. So I end up with 1 times 48 equals 48 over 1, which is equal to 48. Oh, I'm sorry, over 12, which is equal to 4. And I know that foot is my only unit left, but because there's more than 1, it has to be feet. So I know that my answer has to be 4 feet. Okay, and that matches what we got in the table. All right, so here, if you're feeling kind of comfortable with this, you can go ahead and try this one on your own and come back and check your answer. We are working with the metric system here, so you need to know that you have 6 kilograms, so how many grams are in 6 kilograms? 6 being important in kilograms and grams. So we know that we want our answer to be in grams. So our sentence should tell us how many grams there are. So it should say that there are blank grams in 6 kilograms. Okay, so again, make a record of your work before using a calculator. So I want us to try and keep away from using a calculator if we can, but if we need to, that's okay. You just need to make sure to show that work. Show me what you're doing. If you don't show that part of it, you will not earn credit, especially if you get it incorrect. So make sure you're showing your work so we can make sure that you have the process correct. All right, so in this case, the rate would be 1,000 grams per kilogram. So I want to write that out here because that's important. So the rate, 1,000 grams per kilogram. Okay, and then again, it's really important to remember that it's grams per kilogram. So grams per kilogram. And I know that there are 1,000 grams for every 1 kilogram. And then my unit rate would just be 1,000 because it's 1,000 over 1, which is 1,000. So I'm going from kilograms to grams, so I would want to use the grams to kilograms conversion, where grams is on top and kilograms is on bottom. So I'm going to take my 6 kilograms, multiply it by my conversion factor of 1,000 grams for every 1 kilogram. Kilograms and kilograms cancel each other out. I put the 6 over 1, and I get 6,000 grams over 1, which is just equal to 6,000 grams. So I know that there are 6,000 grams inside of 6 kilograms. Okay, and if you think back to our vocabulary example, that makes sense because every time we went down a step, we multiplied by 10. So if we look at this and think about our steps and multiply it by 10 that many times, it should get us to 6,000. All right, so moving right along to the next page. Now we're working with capacity. So we want to know how many cups are in 5 quarts. So that would be our question, so that's important. Again, we're going to underline important information and box our numbers. So 5 I'm going to use because I want to know that's how many quarts I'm working with. And I want to know how many cups in quarts. Okay, again, make a record of your work. And then the rate would be 4 cups per quart. 4 cups per quart. So what I want you to do is I want you to pause and I want you to write that as a rate. And then when you come back, I want you to check to make sure you have the correct rate. Again, this is really important that you try this on your own to make sure you understand what you're doing. Okay, so pause and then come back and we'll check. So when you write this as a rate, it would be 4 cups per 1 quart. And the reason that we're doing cups to quarts is because we're going from quarts to cups. So basically whatever you're doing, so if you're going from quarts to cups, then your rate should have the cups on top and the quarts on bottom. It should go in reverse. Okay. Then I know that I can take that rate and use it to help me find my answer. So first let's write our sentence. So I want to know how many cups there are, so my sentence should be there are blank cups in 5 quarts. And at this point, I do want you to pause, and I would like you to try this one on your own, and when you come back, we'll check your work. All right, so to solve this, you would take your rate, and you would multiply what you know. So I know I have 5 quarts, and I'm going to multiply that by my unit rate to get my answer. I know I put 5 over 1 because it's a whole number. Quarts and quarts cancel each other out, which is good because I want how many cups. Okay. And then I know that 4 times 5 is 20 over 1. 20 divided by 1 is 20, so there are 20 cups in 5 quarts. Again, the work part for this should be getting fairly easy for us. It's making a lot of sense. I want us to try to focus on using the multiplication to get our answers. The hard part is making sure that you're using the right rate. So if you're going, you have to look at what you're going from and to, and then your rate that you multiply by should be the opposite. All right, so what I'd like you to do then, you have one more example here. Exercise 2, how many quarts are in 10 cups? Again, show your work, show the method of how that you went to find your answer. Make sure you have all of your highlighting, make sure you have your sentence and your box numbers. And this will be the problem that I'm asking you to do on your own and bring to class. And if you have any questions, make sure you write those down and also bring them to class so we can go over them.